This is a video recording of review questions for the optional final. We go through these one at a time. I'm going to go ahead and do every single one, starting with number 5 here, which asks us to solve this exponential. We solve exponentials by taking the log of both sides. So what I'm going to do is I'm going to take log base 5 of both sides. I'm doing base 5 because the exponential is in base 5. Log base 5 of 5 cancels each other out. They are inverses. 3x minus 7 equals log base 5 of 29, which I can run on my calculator. So I'm going to go into run matrix, math, log AB. I'm going to do log base 5 of 29. It gives me 2.0922. And then I'll add 7 over. And then divide by 3, 3.017-ish. Okay, there's number 5. Let's take a look at 8. Same thing, it's an exponential. I have e to the 5x plus 4 minus 7 equals negative 3. I need to isolate that exponential first. So the first thing I'm going to do is I'm going to add 7 to both sides. So I have e to the 5x plus 4 equals 4. And the inverse of e is the natural log. So I'm going to take the natural log of both sides. That's log base e, basically. That cancels each other out. 5x plus 4 equals whatever the natural log of 4 is, which is 1.3863. And then I would minus 4, I'll just do it on the calculator, and divide by 5, and I get x equals negative 0.5227. Let's go ahead and take a look at number 10. Number 10, I have log base 4 of 5x minus 2 minus log base 4x equals 2. So the first thing I'm going to do is use my log properties to combine these. When you subtract logarithms, you divide its elements. So 5x minus 2 gets divided by x. Now I can solve this. How do I solve a log? I use exponential. It's the Ferris wheel is the method we used in class. So 4 to the second power equals 5x minus 2 over x. To get rid of that x, I just multiply both sides by x to cancel out that denominator. So what I get is 16, 4 squared, x equals 5x minus 2 with minus 5 over, and then divide by 11. So x equals negative 2/11. Now that's a negative, and you can't take the log of a negative because there's an asymptote at 0. There are no negative numbers for logs, so this is actually extraneous, and the answer is no solution. Alright, let's take a look at 11. On 11, I have, okay, again, 2 logs. I'm going to condense these together. The problem says that when you're adding logs, you multiply. So x gets multiplied by x minus 5. And that's in base 6. So I have log base 6 of x squared minus 5x equals 2. So I'm going to use the Ferris wheel again. It's called exponentiating. 6 to the second power equals x squared minus 5x. So x squared minus 5x. Yeah, it's quite
Senior class officers, please come to the office at this time. Senior class officers, please come to the office at this time. Thank you.
6 squared is 36. I'm going to subtract that over. And then it factors with x minus 9 and x plus 4. X equals 9 and negative 4. That's your answer. But you can't take the log of a negative, so that's extraneous, and 9 is the answer. Alright, let's go. Now, there's not going to be this many logs on the final, but I do have one more here, so we'll go ahead and do it. It's natural log. So I would take 2 natural log of x plus the natural log of 3 equals 7. The coefficient becomes an exponent, x squared. And when you're adding logs, you multiply. So x squared gets multiplied by 3. So then I'm going to do the Ferris wheel. Now, ln is e. This is an unseen base e. So it's e to the 7th power equals 3x squared. So then whatever e to the 7th is, I'm going to divide that by 3. X squared equals, let's run it real quick. It's shift ln brings up e to the 7th. I'm going to divide that by 3. 365.5. And then I take the square root. Only doing the positive because the negative, I could be taking the log of the negative, and that's no good. So we're really on the positive, not plus and minus. So the square root of answer 19.11. Alright, so that's solving exponentials and logarithms. Now we do have 2 word problems here. I can do this right inside the document, I think. You need to be able to write a function. The function is always a times b to the x. A is the starting value. So this would be y equals, I'm starting with $125,000. And it's depreciating at a rate of 9.2. Now b equals 1 plus the rate. So b equals 1 plus the rate, and the rate is a negative because it's depreciating 0.092, because 9.2% is 0.092 of the number. So that would actually be 0.908 as my b value. So 125 times 0.908 to the x power is the function. And I can do a couple predictions. If I ask for, if I say, how much money would you have after, or how much money would it be worth after 10 years? You plug 10 in for x and just run that on the calculator. This, however, is asking for the worth, which is the y value. So if it's worth 80,000, using the formula that we created, what would the x value be? So that's something I'm going to have to solve. Pull over here and solve it. Just one more time, doing an exponential. 80 equals 125 times 0.908 to the x power. I'm going to divide by 125. 0.64 equals 0.908x, and then how do you solve an exponential? You use a logarithm. So I'm going to take log of 0.908 of both sides. Log base 0.908 of both sides. So the log and the exponential cancel, giving me just x, and whatever that is on the calculator is your answer. We'll go ahead and run it. 0.908. 4.6 years. Now this next one is all on the calculator. So when I go into the stats app, we run our regression. Click on these. All yes. All yes. Okay. So we're going to go 1, 2, 3, 4, 5, 6, 7. And we're going to go 72, 87. 1, and I'm going to run regression. So I'm going to do F2, calculate, F3, regression. And I want, it says exponential here, EXP, it tells you where to go. It looks like an exponential. I'm going to go over to exponential. And I'll use ADX. So the equation is y equals 68.32 times 1.086. I'll round that last one to the x power. And then I can make a prediction for 200,000. If I put 200 and did it in thousands, 200 in for y, just like the last one, I would divide by 68.32. Quick. 200 divided by 62. 2.93, we'll call it. And then I'm going to take the log of both sides. And again, you use the log, that's the same as the base of the exponential, which is 1.086. So I'll take the log of 1.086 of both sides, cancels there, giving me just x. And over here, whatever the calculator gives you is use. Okay, so let's move on to That's it for logs and exponential functions. The other function were the rational functions. And let's start with solving. So I'm working on number 4. I have 5k over k plus 2 plus 2 over k equals 5. The common denominator is k and k plus 2. So I'm going to multiply everything by k and k plus 2. Now what cancels here is the k plus 2. What cancels here is just the k, and nothing cancels on the end. So what I get is 5k squared, k times k, plus the 2 distributes, and I get 2k plus 4. And then here I have 5k times k, or k squared, and 5k times 2, or 10k. Now it's kind of nice here because there's 5k squared on both sides, they cancel, and then it's just an easy solve. 2k plus 4 equals 10k, minus the 2k over gives me 8k, divide by 8 gives me 1/2 for k. Alright, let's do 9. On 9, the common denominator is b minus 2 and b plus 2. So I'm going to multiply everything by b minus 2 and b plus 2. That also means this middle term, even though it doesn't have a fraction, we get multiplied by both. And then the last term also on the other side of the equal sign. Okay, so what cancels? B minus 2 cancels. B plus 2 cancels. So I've got a lot left here. In the first fraction, I've got these two. I've got b plus 2 and 2b minus 5. Minus 2 times, nothing cancels, so I actually have both b plus 2 and b minus 2. And in the last one, I have 3 and a b minus 2 on the other side of the equal sign. Give ourselves a little more room. Okay, so we're going to start distributing. So we're going to come over here. I'm going to distribute this up. It's 2b squared minus 1b minus 10 when you distribute that out, minus, now this looks like, wait, how do I do 3 of these? Well, we know what this is. This is a conjugate. So that's really negative 2 times b squared minus 4. It's a conjugate rule. So that's negative 2b squared plus 8. And then on the right side of the equal sign, 3b minus 2. Again, very nice to you. 2b squared minus 2b squared cancels out. So I don't have to do a quadratic. I have negative b, I have a negative 10 plus 8 or negative 2, and 3b minus 2. So I'm going to add b over. Negative 2 equals 4b minus 2. I'm going to add 2 over, which makes 0 equals 4b. Divide by 4, and I get b equals 0 is the answer, which is permissible. Because if you plug that into the denominator, you wouldn't get 0, because it's b plus 2 and b minus 2. So the denominator itself would not be 0. Okay, let's try to squeeze one more in. These videos have a 15-minute time limit, so we're going to have to do a second video for the rest of them, but I think I can get 5 in before my time runs out. This one I'm multiplying by m plus 1 and m minus 1 on everything. Okay, so here m plus 1 cancels. Here m minus 1 cancels. So let's see what we have left. M times m minus 1 plus 5 times m plus 1, and that equals 1 times, do I need times 1 itself? M plus 1 and m minus 1. So I have m squared minus m plus 5m plus 5 equals m squared minus 1 conjugate. The m squareds cancel. Again, very nice to you. Combine like term gives me 4m's plus 5 equals negative 1 minus 5 over gives me negative 6. And then divide by 4, m equals negative 3 over 2. Alright, we'll stop there. Only a few seconds left, and there will be a second